Well, hi everyone, and thanks for coming back. In this lecture, I'd like to talk about one type of case control study, namely the nested case control study, as essentially a springboard for other types of case control studies that I'll talk about in future lectures. But before I begin, let me just talk about the relationships between what I'm going to be referring to as exposure odds and exposure odds ratios and disease odds ratios. And we mentioned this, myself and Elizabeth, one of the TAs, back in the time we were talking about measures of association. Let's suppose, for example, you did a cohort study and you displayed your results as in a table like the one you're seeing on the slides right now. You had a cohort study where you had N1 exposed people, N0 non-exposed people. You follow them forwards in time to see who developed disease. A developed disease among the exposed people, and B did not develop disease among the exposed people. You could measure the odds of developing disease among the exposed people, and that would be A divided by B. You could do the same calculation for the non-exposed people. C of them developed the disease, D of them did not. So their odds of developing disease is C over D. And like we've done before, and as you've done in homework exercises, you could calculate the odds ratio. Let's call it the disease odds ratio, because what we're measuring is the odds of developing disease, separately among the exposed, the top row of this table, and separately among the non-exposed, the second row of this table. It's A divided by D, the odds of disease among the exposed, divided by C over D, the odds of disease among the non-exposed. Let's just label that as DOR for disease odds ratio. Now, if I come along and look at your same data and decide, instead of reporting how much disease developed among the people who were exposed, among the non-exposed, otherwise I looked down the columns and said, well, I have in this data set M1 people who developed disease. I could ask myself, what's the odds of being exposed among all those M1 people who developed disease? A of them were exposed, C of them were non-exposed, so the odds of exposure among the people with disease is going to be A divided by C. If I look down the second column and saw there were M0 people who did not develop disease, I could calculate what's the odds of exposure now among all those people who went through the cohort study and did not develop disease. B of them were exposed, D of them were non-exposed, so B divided by D is the odds of being exposed among those people who did not develop disease. I could take their ratio and I'd be measuring the exposure odds ratio, the odds of exposure among the people who got disease, A divided by C, divided by the odds of exposure among people who did not get disease, B divided by D. Let me call that E0R for the exposure odds ratio. Now here's the kicker. We talked about this before. Mathematically, your answer for the disease odds ratio and my answer for the exposure odds ratio are going to be one and the same. They're mathematically equivalent. That's one of the nice features of odds ratios from a 2x2 table. When you look across the rows and measure disease odds among the first row of the exposed, second row of the non-exposed, take their ratio. I look down the columns and measure exposure odds. We're getting the same answer. The disease odds ratio, the exposure odds ratio are the same. We just call it the odds ratio. Well, now for case control studies, remember what we're going to be doing. In case control studies, we're going to be measuring cases. We're going to be taking cases who already have disease and asking about their previous exposures. We're going to be measuring exposure odds. We're going to take controls, other people who reflect this population from which the cases came from. We're going to be asking them about their previous exposure. We're going to be measuring exposure odds. So in case control studies, we measure exposure odds, we measure exposure odds ratios. So I'm going to be labeling all the odds ratios we calculate in this series of lectures exposure odds ratios. But I'm going to be linking them to what would happen in the underlying cohort study if we created it and followed it. The underlying cohort study being the cohort study that gave rise to our cases. So here's a general point I want all of you to consider. In general, every case control study in this modern description can be thought of as being conducted in a previously created cohort study. We can think, at least in our minds, that all the cases that we're enrolling in our case control studies represent the outcomes that existed, that developed out of that previously created cohort study, even though it wasn't actually created on paper, even though no one actually did it. We can still imagine that it existed. It was followed over time, and these cases of disease that we have in our case control studies were the outcomes of that cohort. It might have been open, it might have been closed cohort, but it existed in the past. The purpose is our controls are being selected to describe that cohort, to answer the question how much exposure existed in that cohort study, either in terms of the people who were enrolled or the person-time distribution of exposed and non-exposed people. So every case control study should be considered as being linked to a previously created cohort study. And in most cases, those previously created cohort studies were never actually created on paper and pencil. The names were actually never recorded, the person time was never recorded, but it still existed. What I want to talk about first is what is called as a nested case control study. And since I've just said that every case control study can be considered something as linked or nested to an existing cohort study, let me put this adjective classical in front of it. I'm going to be talking about a case control study where we actually do know the previous cohort study that gave rise to our cases. Someone actually did that previous study. And for the time being, let's suppose the previous study was a closed cohort study. Someone did a cohort study in the past. They followed people over a period of time. Outcomes happen, and our cases are those outcomes. We're going to select controls to compare to those cases, those outcomes that happened in that previously created cohort study. Now, you might think, why would I want to do a case control study? If somebody already did the cohort study, if somebody already enrolled people at risk for developing disease, followed them forwards in time, recorded who got disease and who didn't get disease, and now I come along and take those people who got disease and call them cases, and take some of the other people and call them controls and start doing a case control study, what am I gaining? Why don't I just use the original cohort study? Well, the reason we do this classical nested case control study, the reason the cohort study itself isn't enough, is because we need new information. When the cohort study was done, when the people were followed over time, yes, the outcomes were observed. So I know the cases, but maybe in that previous cohort, it didn't contain the information I want to use now to do this nested case control study. For example, I might want to look at a brand new exposure that wasn't even existing or wasn't even collected at the time the cohort study was done. I want to see if this new risk factor causes these outcomes that happen in this cohort study. Or, even more commonly in nested case control studies, you did this previously closed cohort study. You published your results. And then someone wrote a letter to the editor and said, the problem with this study is those individuals did not control for confounding by factor X, some factor that people think is a factor that has to be adjusted for. And you didn't do it in your cohort study because you didn't collect information on that factor X. Maybe it didn't exist in terms of knowledge when the cohort study was created. In both cases, what we're talking about is either collecting information on a new exposure or new confounders that were not collected as part of the cohort study. We have to collect new information, and we have two options. We can collect it now on everybody that was in the cohort study, try to contact everybody in the study and ask about a new piece of information, a new exposure or a new confounder, or could I do it efficiently? And that's where the case control study comes into play. Can I collect it on just some of the people? Not the entire cohort, but just a sample of the entire cohort. Well, who are the crucial people to collect this new information on? Well, first of all, the people who got disease. You want to know whether they had factor X or whether they had some unknown exposure, some new exposure we want to study now. And instead of collecting on everybody else in the original cohort, let's just collect it on a sample, the controls that we're enrolling in our case control study. So that's the reason we do classical nested case control studies, is to collect new information that was not part of the original cohort, to address a new risk factor as the exposure, to answer the question whether that new risk factor causes the outcomes that I saw in my cohort study, or to collect a new piece of information that was not recorded initially that might be an important confounding factor. And I'll give you an example of that in a second, but let me just describe that in terms of a picture. Let's suppose you were going to be doing, someone did in the past this closed cohort study. So here you are, you're designing a closed cohort study. You're going to enroll people, smokers and non-smokers, follow them forwards in time to see who dies and who doesn't die. So this is what your closed cohort study is going to look like. Every line's a different person. Every line either ends at the end of the study or with the development of your disease of interest, say death from any cause. That's what the closed cohort experience will look like. What you're going to do is a nested case control study. You're going to use these cases, those X's, as the cases in your case control study, and you're going to select a subset of everybody else as controls, and you can do it in one of two ways. For the nested case control study, what you're going to be doing, let me go back to that previous slide, is to select some of these people at the end of the follow-up study who made it through the follow-up and did not develop the disease. Those are your controls. You're selecting your controls from everybody who did not develop the disease. So your controls are a sample of the people who did not develop the disease. So what you're going to have in your case control study are the X's are going to be your cases and the O's are going to be your controls for the basis of your nested case control study. So here's what the full cohort study would have shown you. If you had known the exposure in the cohort study, you could measure how many people were exposed and how many people were non-exposed. You'd have N1 exposed, N1 non-exposed, A people developed the disease, C people didn't develop disease. You could measure risk ratios or disease odds ratios that we talked about before when we talked about closed cohort studies. Now you're coming along with your nested case control study. You're selecting your controls from the group of people who made it through the follow-up period and did not develop the disease. So if I go back to that 2x2 table, this column, capital B plus capital D, is the potential source for your controls. Those are the people who did not develop the disease in your original closed cohort study. You're going to enroll a sample of those people. You're also going to enroll all the cases. And you're going to ask all your cases and the sample, your controls of the non-cases from your original closed cohort about their previous exposures. And the previous exposure might be some factor that was not collected as part of the original closed cohort study. So what you're going to do is select controls from your universe of all potential control, all the non-cases that the people who did not develop disease in your closed cohorts. You're going to be measuring exposures among the cases and controls. You're going to be calculating an exposure odds ratio. I'll show you that in a second. And that exposure odds ratio should estimate what the disease odds ratio would have been in your original closed cohort if you measured exposure status on all the potential controls. And finally, remember when we talked about odds and risks? I talked about if the proportion, the risk is small, the odds is small, and the value for the odds ratio, the disease odds ratio, is very similar to the value for the risk ratio you can get from cohort studies. So if you're measuring an estimate of the disease odds ratio in your cohort study, you're also estimating the value for the risk ratio in that cohort study if the risk is rare, if the cumulative incidence of the disease is rare. So this is what your nested case control study is going to look like. You're going to enroll as your cases everybody who got the outcome in that original closed cohort study. You're going to be asking about their previous exposures. You're going to ask how many of them were exposed to some exposure, how many of them were not exposed. And I'll give you an example of that in a second. You're going to be measuring the odds of exposure among your cases. You're going to be selecting as controls a sample of people who were the non-cases, the people who did not develop the disease in your original cohort study. You're going to enroll, say, M sub 0 people, and you're going to ask them how many of them were exposed and how many of them were not exposed in the past to your risk factor of interest. You're going to measure the odds of exposure among the controls. And if the controls represent everybody who potentially could be a control, if they are essentially a representative sample of all the non-cases of disease, the capital B plus capital D people in your original cohort study, what you're going to be doing is from your exposure odds ratio calculation in a case control study, you're going to be estimating what the disease odds ratio would have been in the original cohort if you measured it on everybody. if you measure the exposure on everyone. And if the disease is rare among the exposed and non-exposed, you're estimating also what the risk ratio would have been in that original closed cohort study. Well, that's a lot of math and a lot of pictures, but now let me try to bring this home to you in an example of a nested case control study. It's a very old example. The study was published, in 1983, 30 years ago, by my friend and colleague Walter Willett, who's an epidemiologist here at the School of Public Health. I give you the citation there if you ever want to check it. Basically, what Dr. Willett had and what he wanted to address was the relationship between an exposure, serum selenium, a measurement in a person's body that's reflecting the diet that person is eating, and the risk that person will develop a cancer. Well, what Dr. Willett had access to was a data set from a previously created closed cohort study. The closed cohort study was actually a randomized controlled trial. What he had data on was data from a previously performed experimental study, a randomized controlled trial called the Hypertension Detection and Follow-Up Program. You can read about the reference of that by looking at the references in Dr. Willett's paper if you want. That study, the Hypertension and Detection and Follow-Up study, had nothing to do with selenium and cancer. It had to do with different ways to try to treat hypertension, to try to treat high blood pressure. But what the investigators did when they performed the Hypertension and Detection and Follow-Up study previous to 1983 is they collected data on individuals, not just based on what their blood pressure was and what sort of treatments they have and whether those treatments worked. They also collected information on other outcomes. They built a registry, and they could determine numbers of people and who were the people who in the follow-up period developed cancer. It wasn't a primary outcome in their study, but they collected that outcome information for the potential for future studies. What they also did is they took blood specimens for essentially half the people in that large hypertension and detection follow-up study, and they put those bloods in freezers. So now imagine you're Dr. Willett. It's 1983, and you're given access to those freezers of bloods. You know which of those blood specimens came from people who later went on and developed cancer. So you have the potential of enrolling those cancer patients as cases in your case control study. You also have blood specimens on other people who did not develop cancer, potential controls for your nested case control studies. You could take those bloods, analyze them to see what the selenium levels were among those people who developed cancer out of the experience of the Hypertension Detection and Follow-Up Program, and also on a series of non-cases, your controls. So that's what Dr. Willett had. He had at his availability 4,480 individuals who were part of the original Hypertension Detection and Follow-Up Program and had blood specimens taken and were stored in this freezer. So that's the data he had available to him. Now, he knew from the information that was collected on these people that of those 4,480, 111 of them went on and were diagnosed with cancer during the follow-up period. You definitely want those bloods. So if you were Dr. Willett opening the freezer drawer, you'd be taking out all the frozen bloods for those 111 cancers. Now, do you take everybody out? If you do, you are essentially recreating the closed cohort that gave rise to those 111 people, or do you become efficient? Do you just select some of those people of the remaining blood specimens to be the controls for your case control study? And that's what Dr. Willett did. He enrolled 210 non-cases into his study as controls in his case control study. He took 210 of the other blood frozen specimens. So in total, he only ended up analyzing 321 of the 4,480 blood specimens that were available to him to use, analyzing the bloods of all the cases who developed cancer and a sample of the other people who did not develop cancer. Well, it's very efficient. He's only analyzing 321 blood specimens rather than the 4,480. Well, this is what he would have seen if he analyzed all 4,480 blood specimens. We knew that 111 of them later went on and were diagnosed with cancer. When he analyzed those blood specimens, it turned out that 57 of those 111 had low selenium levels and 54 had high selenium levels. If he analyzed all 4,369 other people, he'd again have the makings of his close cohort. A certain number of them would have been people with low selenium, a certain number of people would be high selenium. The only way he would know those numbers is if he analyzed all the remaining 4,369 to determine how many people had low selenium in that group, let's call that B, and how many people had high selenium, let's call that capital D. That's what he would have had for his data set if he had analyzed all 4,480. He could calculate the risk ratio from that data. He could calculate the odds ratio, the disease odds ratio. The risk ratio would be 57 divided by N1, the total number of people with low selenium levels, divided by 54 over N0, N0 being the total number with high selenium levels. Mathematically, that's equal to the odds of exposure among the cases, 57 divided by 54, divided by the odds of exposure among everybody who was in the source population, everybody in the closed cohort. So he could calculate that if he measured seleniums on all 4,480. He could do the same thing. He could measure the odds of becoming a case. He could measure the odds of becoming a case of cancer among everybody with low levels of selenium. That would be 57 over B. The odds of developing cancer among everybody with high selenium levels, 54 over D. That would be the value for the disease odds ratio, with mathematically, again, is the how common, how is the exposure among the cases, the odds of exposure among the cases, 57 over 54, divided by the odds of exposure among everybody who did not get disease, capital B over capital D. Now remember what Dr. Willett did, he only took a sample of 210 of the 4,369 non-cases to be in his case control study. Hopefully, when you analyze the exposure odds among those 210, you're going to get an estimate of what the exposure odds among everybody who could have been selected as a control among all 4,369. That's the power, the efficiency of the nested case control study. So this is what Dr. Willett's results were. He had 111 cases, 57 of them had low selenium levels, 54 had high. The exposure odds among the cases is 57 over 54. Among his selected 210 controls, 84 of them had low levels, 126 had high levels. 84 over 126 is the observed exposure odds among the selected controls. And hopefully, it's a good estimate of what the odds would have been on all potential controls, all the capital B plus capital D, all the 4,369 potential controls that he could have selected. So what Dr. Willett then calculated and his actual nested case control data is a value for the exposure odds of 1.6. That's the measure of association. Now the question is, how can we interpret that measure of association? Can we interpret it as somehow reflecting the influence on selenium on the incidence of the development of cancer? And the answer is yes, because we can link this number 1.6 to those numbers we would have loved to have created if we had the full cohort study. We can link it to the risk ratio and the disease odds ratio that we could calculate if we had the full closed cohort data set. Because, going back now, the selected controls with their odds of exposure of 84 over 126 hopefully is reflecting the exposure odds among everybody in the original cohort study who could have been a control, the capital B plus capital D people. Therefore, the exposure odds ratio we observe in the case control study, 1.6, is estimating what the disease odds ratio would have been in that underlying closed cohort study if we analyzed all 4,480 blood specimens. And finally, since only 111 people out of the 4,480 people developed cancer, the incidence of cancer is small. Therefore, the disease odds ratio in that closed cohort should estimate the risk ratio in that closed cohort. And finally, the exposure odds ratio, therefore, is not just estimating the disease odds ratio, it's estimating what the risk ratio would have been in that full cohort study. And that's the glory, the strength of the nested case control study. We're able to estimate what would have happened in the original full cohort using only a fraction of the data, using data collected on the cases and data collected on a series of the non-cases. And that's the strengths of the nested case control studies. Next time I want to talk about another type of study Dr. Willett could have done if he had chose to do with the same data set, not a nested case control study as the way we've just described it, but using another type of study known as the case cohort study. We'll talk about that next time we are together. See you then.